Well, I couldn't help myself. This came in the mail today. What is this? Well, it's something that's way too big for my workbench, I'll tell you that. So let me open this box and we'll get to it from there. This here is, I guess as you've seen by the title, a Rigol DS1054Z oscilloscope. This is the big boy scope compared to my analog scope and compared to my little digital guy. So, manual. Okay, it's going to be good reading, good bedside reading. Let's see, what else is in there? Oh, sweet, a 90-degree lead. That's awesome. We'll get to that in a second. Two scope leads here. A USB, like a printer port type USB. Those guys there. So I sure hope this thing came with 4 scope leads. Aha, yes, it did. There we go, nothing there, nothing there. Okay, piece of cardboard. And, oh yeah. I wish you would be here to see it with me, but this will just have to do. Oh baby. Rigol DS1054Z. This is not the greatest scope that was ever made, but it is very likely the best bang for the buck beginner scope. Oh baby. First things first, first impressions. This thing is freaking tiny. It's absolutely tiny. Let me get a measuring tape. It is like 35 centimeters, a foot, by about 6¼ inches, or 16 and a half centimeters. And it is thin. Look at that. This is not a thick boy. It's about 4 and a half inches wide, or 11 and a half centimeters. This thing is ridiculous. It's tiny. Buttons feel very nice. I have no comparison, by the way, just the analog scope that I've unboxed or revealed before. This thing is freaking sweet. Well, it's not really made to be looked at. It's made to be used. Ooh, warranty void sticker. Don't know if I can afford to pull that off at the moment. But yeah, let me get this all set up and plugged in, and you guys will be here with me when I turn it on for the first time. So I'm really happy that it comes with a 90-degree lead, because the way I want to use it is like this. Well, I guess I'll have to use it over here, or laying on its back, so that you guys can see the screen and we can do a little bit of work here. This is as far zoomed out as I can get with my current camera setup. I'm running an 18mm lens, so I got a little bit of space, but not a lot. So I need to be able to move this in and out of shot, sort of maybe over here or something. And if the IAC cable was poking straight out, it wouldn't have as low profile. I might look for a lower profile cable, like a really sharp 90-degree bend, but for now this will do. So let's see how long it takes to boot up. You ready? Oh, nice. It has a really nice ka-chunk switch there. Okay, I hear the fan going. The screen is not super bright, but mind you, I'm blasting it with light from the front here. Ooh, some clicking. While that happens, I'm going to open some scope probes. Oh, there it is. There's a little auto flashing up there. I don't know if that's the trigger. I have not read through the manual yet. This is just all off the cuff. And that's why you notice this video is not called a review. I do not want to review a product until I've used it. Also, this is not a sponsored product either. I wish. If Rigol wanted to send me one of these, I would accept it in a second. So the probes it comes with is the PVP2150, rated to 150 volt on 1X and 300 volt on 10X, Cat 2 rated, and there's a little compensation port. It's pretty thin. It's like a maybe a RG174 or something like that cable. It doesn't say on it. I'll plug this into channel 1 because we already have channel 1 open here. Ooh, that locking mechanism feels absolutely positive. I like that. Alright, let me see if I can turn up the brightness. Go system, power set last. It's not extremely bright under these lights. There must be a way to change that. Let's go down. Options. Setup. Editor off. Clear. Apply. I'll have to read the manual on that, because if I have to shut off some lights, I will. But the ideal would be to show you guys what I'm seeing. I have to take a look here. Today is not the same day. So when I was unboxing this, I realized it's an amazing tool, but it's not particularly easy to use if you've never used a digital scope before. So it's not like it's difficult to use in general, it's just that to get the layout of the buttons and what everything does and get it a little bit more down to muscle memory is a bit more challenging. So I figured I would play with it for a few days and then try again. Right, so here we go. We just have channel 1 trace here. Actually, we can center. So what's really nice is that the this little knob here is the vertical position of the trace, and pretty much all the knobs, if you click them, they'll center everything. Okay, so like that, centered. Down here, it's a little bit hard to get used to, but you actually have to check which channel is highlighted to see what this knob does, because this knob will work all the channels. Clicking the channels once will turn them on, and then clicking them again once they're selected. So see selected, click it again, we'll turn it off. Alright, so we've got our probe here. I have bent the tip a little bit, so you got to be a little bit careful with these. Try not to ham fist them. I will plug it into the test port, and there we go. And so now, like, let's see if we can see this a little bit clearer. So we will lower this down to a little bit lower on the screen. Okay, so down there. And now to change the volts per division, so turning clockwise decreases the volts per division, and counterclockwise increases the volts per division. So very nice there. We can move our trigger level. Everything to do with the trigger is over here. So we can move our trigger level up and down like that. Our time base is over here, the horizontal. So same thing. Okay, faster time base clockwise, slower counterclockwise. And as you can see, we get very nice displays here. And this is the left and right. And you can just click that to center it. Click this to zoom the wave. Very nice, very responsive. It's a bit slow on certain little things, but it's because this is a few years old, this design already. Also down here, you can set with these buttons here your measurements, and once you have them set, they stay down there. You can clear them through the menus, but they stay down unless you override them with more. So right now I set the frequency, that's a 1 kilohertz sine wave. Makes a lot of sense, okay, because that's what the test signal is supposed to be. And it shows us voltage peak to peak is 2.98 volts, so nearly 3 volts peak to peak, so from here to here. And if we look our channel 1 DC coupled, so a little DC right next to it, 500 millivolts, that means that every division is half a volt, so we should have 6 divisions from bottom to top, so 1, 2, 3, 4, 5, 6, and that's pretty well dead on, which is pretty nice. So yeah, I figured we would scope a couple things and take a look. Mind you, I am not an expert at scopes, so if you've been playing with scopes for your entire life, that's you. For me, I've used a few automotive scopes, like snap-on scopes, which work quite a bit differently. It's more catered to the layperson. But yeah, I'm just learning this stuff. So let's get out the signal generator and see if we can read some generated signals. So I've got my little function gen here ready to go. I have the jumper at the lowest setting, so it should be 1 to 10 hertz. Not sure if we'll get that low. And I'm not sure how much voltage comes out of here anymore. I forget these things. So I'm going to hook up the ground. Right, there's ground. Yeah, ground. That's right. Hooked up. That crocodile clip is very sturdy, which is sort of nice, sort of not. We're going to hook up to the square wave. Okay. And I'm going to say OK. Alright, so this is all gibberish right now, which is perfectly fine. Let's try to change our scaling a little bit. So it should be 10 hertz. Don't think that's 10 hertz personally. And by the way, I do trust the scope more than this this sketchy function gen. So go 2 volts per division here, and we should be able to trigger on that. Yeah, we are triggering on it. Frequency though is 820 kilohertz. I don't feel that is right for the jumper being in the 1 to 10 hertz range. I'm gonna swap this. Oh, it didn't actually do anything. You know, I'm starting to think my kit is not all that great. Let's see if we can change the time base here. Oh, are we getting something more reasonable? Frequency 14 hertz. Yeah, I'm at the 10 to 100. I feel like it doesn't work all the way down here. Oh, it does. It does. There's a lot of noise riding on top there. There we go. And what are we getting? There we go. 1.18 hertz. Change this dial a bit. Ooh, yeah. This function gen just is not happy. There we go. Yeah, it's not very happy. Let's see if we can change the bandwidth a little bit. Memory depth. Auto. Change it with this. Not sure if that's a good or a bad thing. Yeah, I don't know. I don't know what's going on here. This thing is not happy. Alright, so we'll move down to 100 to 3 100 hertz to 3 kilohertz. I'm going to clear this. See if we can get a trigger here. Okay, we are getting a trigger. So this device, this this function gen seems to be much happier at higher frequencies, because you see a little bit of wibbly wobbly there, but overall not too bad. I'm going to swap to the sine wave. There we go. Got to drop. See, we lost a little bit of voltage there, so I got to drop my. Whoops, that's a horizontal base. See, my habit is to grab this guy, but it's really this here for the trigger level. See if I can fix the tops of those. There we go. Drop my trigger level again. There we go. See, get this to trigger just fine. We're doing a frequency of 400 hertz. Let's go all the way. Let's top out this function gen. I may want a higher quality function gen in the future. But there we go. So what are we saying now? 143, 144 kilohertz. It's not bad. What are we topping at here? This is as fast as it goes. 1.21 megahertz. And that is as severe as the sine wave can get. Yeah, this function gen is not great. Pretty sure I'm going to want to pick another one up. So what's also good about this scope is if you want to take a single shot, first of all, if you want to say, okay, look, I need to look at this, you can hit the stop and it just stops. So now you can actually go and take your measurements. You can hit run again, it'll run again. So that's good. But if you just want a single event, okay, so let's say I power this off. So function gen is not powered right now. You go single shot mode. Over here it says wait. That means it's waiting. And then I'm going to hit OK. It did something. it caught something. So let's see if we change the scale. Oh, look at that. So see, we did get something. That's interesting. And there's our wave there. So this is all stopped. This is all the data that it picked up. So that's pretty good. And I'm getting more comfortable going through the knobs, you know. Go 1 volt per division. Drop it down a little bit so we can see it better. Maybe we'll go half a volt per division. Go, drop it down again. Now we can change our scale. Look at all the noise that's picked up here. And we can hit run again. See if we can trigger on this. For some reason it's not triggering particularly nicely on there. Let's grab... Oh, you know what? We might be at the bandwidth end of our probes. Because 1 point something megahertz might be a lot for a ×1 probe. I think if you hit the ×10, it works a bit better. Not 100% on that. Let's try and change our triggering type so we can go menu. Pretty much every time you see a menu in a box, it just means like the menu for that box. So this is the menu for triggering. This is the menu for the horizontal time base. And you've got other stuff over here, which is pretty nice. So in the trigger, so type, we've got all these types of triggers. So edge trigger, sure. Source, we'll check the slope. See, we'll grab the way up, see if it'll grab that. No, it doesn't seem to like that. I'm going to change the time base a bit. Because it is grabbing it, but for some reason, not particularly well. It's possible the signal is not clean enough. Let's try to drop this down a bit. Now we're maxing out everything. This way. And grab the horizontal. Grab that. We'll drop it down a bit. It's triggering on that just fine. We're at 122 kilohertz. This thing climbs like crazy. Grab the trigger, scale it up a bit. Let's see, it grabbed it now, 1.22, 1.20 megahertz. It's a nice scope. It works fairly well. I'll switch that to triangle wave and see what it looks like. That was sine, I think. That was sine. Where's triangle? Triangle wave over here. Doesn't look much like a triangle wave to me. There we go. A little bit more pointy there. Yeah, I feel as though this function gen is not so great. But let me show you some other cool stuff that you can scope that aren't just made by a function gen. So what you see here is a little brushless DC motor. Well, it's a three-phase DC motor. Technically it's an AC, whatever. It's for a quadcopter. It's actually for a fairly large quadcopter or a plane. And what I have is I've scoped all three of the wires, all three of the phases of this motor. There's yellow, black, and red, and I've hooked those up to yellow, blue, and pink, so it'll be close enough to what we should expect. Now I'm going to try to set up the scope to try to pick up the waves by just spinning it, the voltage generated by just spinning it. So I don't think we're going to make a whole volt. So I'm going to grab the yellow channel. I'm going to put about 200 millivolts per division. That should give us enough space. I will grab my trigger. I will drop it down to, well, you know what? It's going to be an AC wave. So I think I'm going to center the horizontal position, and then I'll grab the trigger and I'll just grab it over like that. 200 millivolts. You know, maybe I'll move it down one more. I'm really trying to get this right the first try. Okay, so I've got the blue channel, channel 2, and pink, so I need to turn on blue. Okay, and again, all the phases should make the same amount of voltage, so I'm going to set it to 100 millivolts. And I'm going to center it. Done. Need channel 3. Same thing, channel 3. 100 millivolts. And it's already centered. I'm going to center it again, just in case. Okay, so we've got all three on here. Now I could spin this to see if I was right about the setup, but that's not as fun. I actually want to set up a single shot mode. So you can go here and hit mode, and then it'll cycle to normal, then one more time it'll cycle to single. But what I really love about this guy is that you just hit single like this, boom, and now it's waiting. I love the fact that you have a hardware single button for single shot mode, and you have a run stop button there. So I'm going to hold down the wires. Oh, just look at that, just me getting in the way here. I gave some of my inductance to it. I'm going to run it again. Oh, you know what I didn't set up? The time base. So let me set up the time base. 200 nanoseconds. Yeah, that's way too fast. Let's go, 20 milliseconds. That's about right. I'll go single shot mode. Now I should be able to just spin this. I induced some... let's try that again. That's interesting. There it is there. Let me see if I can set this back up. Maybe to scale. Maybe I'll move my trigger level up a bit. And let's try this again. Here we go. So we got something. Let's zoom into there. Ooh, looks like we went off the scale. Okay, so this thing is generating more voltage than it looks like. But what's great is you can just rescale all your figures. There we go, that's good. Channel 2. That's good. Channel 1. Okay, and let's give that another shot. Single shot mode. Boom. Look at that. beautiful. So you can see right here as it's building speed. And then I can move this over like that. We can take a nice look at those beautiful colors. Look at that go. There, see how the maximum speed was achieved here because it makes the maximum voltage. Then the voltage drops over time. That's amazing. So it makes these nice, cool little patterns. So this is another thing about the oscilloscope is now I know, I'm looking here, voltage peak to peak is 1.5 volts. So I need a fairly small voltage drop diode if I want to put this through a bridge rectifier to pick up some voltage from this. So it's stuff like that that's really doable with a scope, but basically at this point I really need to work on this thing some more, get more comfortable with it, play with it, and eventually I'll be able to give you a full review. But until then, thanks for joining in. If you'd like to help offset the cost of this, it is about $600 Canadian pesos. You can join my Patreon. And I have to give a big thanks to my 2 patrons I already have at the time of the filming of this video. But I'm sure more of you will join, which is great. If you'd like to support me without giving any money directly to me, just watch my videos and share it with your friends. But either way, if you're stopping by for watching my video or for commenting, I thank you very much for watching.